hopefully everybody can hear my voice. Otherwise, they're looking at this sign and they're hopefully encouraged to get the sound up and running so they can hear the video. This is a lesson on c7s7p2, that's chapter 7, section 7, part 2, in the Geometry Chapter 7 study guide. So, this section, the last section in chapter 7, is on solving right triangles. When you solve a triangle, that means you're trying to find all the unknown side lengths and all unknown interior angle measures. Now, be aware that this particular skill can be done in many different ways. The first thing I do wouldn't necessarily be the first thing you might do. There's different techniques that you can use to find answers. Basically, we have some great tools in our toolbox when it comes to right triangles. We've learned about the Pythagorean theorem. You might be able to use that. If you have 2 sides out of 3, for example here, you could use the Pythagorean theorem to find the hypotenuse. Leg squared plus leg squared equals hypotenuse squared, right? You know that all 3 angles on the inside of any triangle add up to 180, so you could use that. For example, here we have a 90-degree corner and a 37-degree corner, so we could take 180 minus 90 minus 37 to find this angle. And then lastly, we have trigonometry. We've got sine, cosine, and tangent, which create equations that we can solve to find things like angles or side lengths. So keep in mind all of these things. The Pythagorean theorem, the interior angle, sum of 180 degrees, and then you've got sine, cosine, and tangent. So because we have so many tools, we've got different methods of coming up with the same correct answers. And if you have the same answer as your neighbor, but you found it in a different way, it's certainly possible that you both can be correct. All right, so I'm just going to do these problems the way that I would do them. The first thing I would do is I would find the measure of angle P. I know that all 3 of these angles add up to 180 degrees. So for me, the measure of angle P, I would say 180 minus 90 minus 37 degrees. So the measure of angle P is 53 degrees. So now I'm done finding the angles. I've solved the right triangle, at least where angles are concerned. They knew what 90 was, they knew 37, and I just needed to find the last angle of 53. Okay? Now I'm going to move on to side lengths. I do not know these 2 side lengths. So I'm going to call this one x. This x, I could use trigonometry to find this. If I use this as my reference angle, this x side would be my opposite, right? And then this one that's been given to me already is my hypotenuse. So if I combine these 3 things together, I have an angle, I have a side I want to find, and I have a side length that's been given to me, I can use sine. Sine combines the 2 sides, opposite and hypotenuse, in a right triangle. The sine of your angle is the opposite side over the hypotenuse side. So the sine of 37 degrees, if I put that into my calculator, oops, that's a no. Calculator, is 0.601815 approximately. Writing this as a fraction allows me to cross multiply here. 1 times x is x. 22 times this decimal gives you an x value of approximately 17.6 units. They want me to round off to the nearest tenth, so that's what I did. And then finally, I want to find that last side. Now you can do that in a couple of ways. You could use the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, assuming that this leg is 17.6. Or you can use some trigonometry. I'm going to do that. I'm going to find side length y. I know that's the adjacent side. So if I want to use the adjacent side and the hypotenuse side, and this reference angle, I can do that. Adjacent and hypotenuse, I wouldn't use sine because that's opposite of hypotenuse. Cosine would be the one I would choose because that creates a fraction of the adjacent over the hypotenuse. So that's what I'm going to do. I'm going to say that the cosine of 37 degrees equals the adjacent over the hypotenuse. So I'll type this into my calculator, and it gives me 0.7986 approximately. And then if I cross multiply, I can do that if I create a fraction on both sides. So I put a 1 underneath this value to create the fraction, and then I cross multiply. 1 times y is y. 22 times this decimal gives me, oh no, 17.6. I'm sorry, I copied this one wrong. This is 13.2. Oh my goodness, I looked up in the wrong spot on my paper. There we go, 13.2. This is the one that's 17.6. There we go. So now I found the 2 unknown sides and the 1 unknown angle. Once you found all the parts that were missing, any missing angles and any missing sides, then you have solved the right triangle. So I know I'm done. Now on this one, they gave me 2 sides and 1 angle. So I think the first thing I'm going to do is I'm going to use the Pythagorean theorem. These are my 2 legs. I know that leg squared plus leg squared equals hypotenuse squared. So if I set it up that way, I should be able to find the length of my hypotenuse. 11 squared is 121, 18 squared is 324. So I get 445 equals the hypotenuse squared. Solving for h, I can cancel the square with the square root. So the hypotenuse is approximately 21.1 units long. Now, I need to find one of these angles. There's a lot of different ways we could do this. I'm going to use some trigonometry. I'm going to say that I'm going to pick P as my reference angle. I could have picked N, but I decided to pick P. That means that this side would be my opposite, and this is my hypotenuse, which I know is 21.1, and then this would be the adjacent over here. So in order to find an angle, you actually need 2 sides. Now we could use any 2 sides because we now know all of them, but I'm going to choose the 2 original ones, opposite and adjacent. Sine is opposite over hypotenuse, so that equation won't work. Cosine is adjacent over hypotenuse, so that won't work. Well, I mean, it will if I want to use this, but I said I didn't. So if I want to use specifically these 2 sides, tangent would be the one, tangent of angle P, would be the one that I would choose. So tangent is opposite over adjacent. And as you can see, we're going to be using the inverse function. When you have your side lengths and you want to go back and find out what the angle was, that can be found by using the inverse. So if I take 18 divided by 11, that'll be my first step. That gives me a decimal of approximately 1.63. Actually, it's 1.63 repeating exactly. And so if I have my fraction value or my decimal approximation of that, and I want to go back and figure what the angle was, for that we don't use tangent, we use tangent inverse. So on your calculator, you find your tangent inverse button, enter 1.63 repeating, which would be 1.6366363 as many times as you want to enter it, and then hit enter. So it turns out that angle P comes up as about 58.5 degrees. Again, I'm rounding off to the nearest tenth of a degree. And so if this is 58.5 degrees, the easiest way to find the last angle here would be to say, okay, the measure of angle N, if I know that the three of these angles add up to 180, I would simply take 180, subtract this corner, which is 90, and then subtract this corner, which is 58.5, and that'll give you the measure of angle N to be approximately 31.5 degrees. So now we have all three interior angles on our triangle, and we have all three side lengths. So that means I have solved my triangle. All parts that were unknown before are now known. So, let's see here. The last two examples down here at the bottom of the page, again, there's different ways of going about these. For the first one, let's call that number 1. Since this is 24 degrees, I should easily be able to find the measure of angle T by taking 180. If all three of these are 180 total, I could take 180 minus 90, which is this corner, minus 24, which is that corner, and what remains will be the measure of angle T. So the measure of angle T is 66 degrees. And if you want to label it, go ahead. So at this point, you're going to have to use some trigonometry. You don't have any other options. I'm going to say that I'm going to use 66 degrees as my reference angle, which means that this side here that they gave me is my opposite. This one is always the hypotenuse, and that means that this one over here must be the adjacent. So for example, if I want to find the adjacent side, let's call that side A. I can use these two, the side length they gave me, in combination with adjacent, in order to find it. Or, for example, if I wanted to find the hypotenuse, let's call that side H, I could combine the opposite with the hypotenuse. Let's do that. So if my reference angle is 66 and I want to put these two together, so I have an angle, I have one side and I want to find the other side, putting these two together would help me do that. I just have to figure out which function to choose. So is it sine, cosine, or tangent that gives you a fraction that combines the opposite and the hypotenuse? Well, hopefully you know by now that that's sine. We've done a lot of practice problems like this earlier in the chapter, so. The sine of a reference angle is equal to the opposite, which in this case is 33, over the hypotenuse, which is our unknown value h. So if I find the sine of 66 degrees, that, in my calculator, is about 0.9135. And then if I write that as a proportion, I'll need to have a fraction on both sides, so I'll put this over 1 to make a fraction here and there. And then h times this, you just write that like so. 1 times 33 goes on the other side, that's 33. So if I divide both sides by the decimal value in front of h, just like we normally solve an equation, then my hypotenuse length ends up being approximately 36.1 units long. Okay, so we have all three angles inside, good, and we have 2 out of the 3 side lengths. We have the opposite side and we have the hypotenuse side length. So the last step is to find the adjacent side length. you could either use the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, finding one of your leg lengths. Or you could use cosine, for example, adjacent over hypotenuse, or you could use tangent, which is opposite over adjacent. Anything that includes this side as the one thing that is unknown will work. Let's use the Pythagorean theorem. If I have leg squared plus leg squared equals hypotenuse squared, let's see, 36.1 squared is 1,303.21. 33 squared is 1,089. So I'll subtract 1,089 from both sides. A squared is about, these are all approximate because the hypotenuse length is approximate. So 1303.21 minus 1089 is 214.21. So then I'll just cancel the square there on the adjacent length by taking the square root. And so my adjacent length is about 14.6 units long. Now, if you want to try example number 2, I'm just going to write the answers over here on this adjacent page. Number 2, the measure of angle E turns out to be about 47.3 degrees. This side right here, UM, ends up being about 20.6 units long. And then the measure of angle U ends up being about 42.7 degrees. So remember, there's not one way to do all of this. Okay, you can use all the different types of tools at any time that's appropriate. Remember, these are the list of tools. The Pythagorean theorem, which is leg squared plus leg squared equals hypotenuse squared. We can use this whenever we have 2 sides out of 3 and a right triangle. If you have 2 angles out of 3, you can use the interior angle sum of 180 to find the third one. Or if you have any 2 out of the 3 of these things, if you have 2 sides and an angle, or an angle and a side, you can find the other thing by using sine, cosine, or tangent. So hopefully you can figure out how to find any of these. I might start finding this side right here by using the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, and then maybe use some trigonometry to go from there. And then hopefully you can come up with these answers on your own, using your own methods and steps.